All right, reflection. So reflection, your book has a really long, complicated definition. The simple version, I would say, is the bouncing back of light off of a surface. So reflection is when light hits a surface and it bounces off of that surface. Okay? But it does it in a very, very particular way. And it's called the law of reflection, not to be confused with the law of refraction, which we'll talk about.
Didn't we talk about both of those already?
Huh?
Didn't we talk about both of those already?
In Physics 1, which is why I'm not going to go into depth with them. Just going to remind you what they are. So the law of reflection is the angle of incidence equals the angle of reflection. Ooh, I spelled it right this time. Okay, so the it looks like this. So here's my surface. Here is the what's called the normal line, which is just a vertical line off the surface. And then here's your light. It comes in and bounces off. And the angle the light comes in equals the angle the light goes out. Okay? That easy. That easy. Just as easy as taking a test you aren't ready for. That easy. Okay. So, refraction. So, refraction is when light bends when it enters into an angle. So, light entering. Light, we'll say changing mediums at an angle bends. So when light comes in at an angle, it's going to bend. Okay? Super easy example of this. Okay? I've got my little pencil in the water, and if you look at it, you'll notice that the pencil looks bent. Like the pencil looks like it's like broken in half or something like that. The reason for that is the light is refracting. So the light is entering into the water, then it's entering into the glass, and then it's going into the air. And that combination is going to cause the light to bend and behave differently. So that's what refraction is. So refraction is that bending of light that you can see. Okay? So pretty straightforward there. Again, here's an image of it. So if you have some surface, okay, and again, you've got some normal line. The light comes in, but then it bends. So the angle it comes in and the angle it comes out are not the same. Okay, it's worth noting this law of reflection and the law of refraction are different. There is a law of refraction. It's called Snell's law. We will look at it later. We're not going to look at it today because it's n1 sine 1 theta equals n2 sine theta 2. And it's not bad once you've seen it, but like if I just threw it up here, you'd be like, what is that? And we'd have to explain the whole thing. So for right now, know that there is a law of refraction. It is an equation. We will do it later. Okay. All right. So that takes care of reflection and refraction. Any questions on those two things? Hopefully the review. Okay. All right, converging and diverging. So converging is when light gets brought together. and diverging is when you spread light apart. We're going to mostly deal with lenses in this unit. So one type of lens looks like this. Another type of lens looks like this. This is sometimes called a converging lens because when the light comes in, it converges to some point where it meets. That would be called converging. It's bringing the light together. Diverging lenses spread the light apart, so they look something like this. Okay. Lenses use refraction to bend light. Mirrors use reflection. So lenses make images using refraction. Mirrors use images using reflection. Again, we are mostly doing lenses, so we are mostly going to be doing refraction. Mostly lenses, so mostly refraction. And the reason we're doing mostly lenses is 1, time, and 2, I want to be consistent with what we're doing, so I don't want you being like confused as like, oh, is this a mirror thing or a lens thing? So we're just going to mostly stick with lenses. Okay. 2 things that you should know what they are. I'm going to show you them shortly, which will make more sense. But for right now, just to describe them. So the principal axis is a straight line in imaginary straight line through the center of a lens / mirror. And it looks like this. That's it. It's an imaginary straight line through the middle of the lens. That's it. So that's what it is. The reason I say it's imaginary is because it doesn't really exist. You don't see it. It's not like you have to put your mirror hanging on something. Like it's useful in drawing pictures, which is why I want to define it. We're going to do it in all of our diagrams, so I want to make sure you can see what it is. Okay. Second one is the focal point. It's where parallel light gets focused. So, see how the light got focused here? That's called the focal point. Now, you're saying to yourself, Mr. B, this one didn't have light focused anywhere, so where's the focal point? It does have light focused. Backwards. I know, see? Exactly what I said.
Did we talk about this with special relativity?
No. Maybe you just explored it on your own in your free time.
Oh, maybe. I think we talked about like how the light looks different from.
Yes.
Okay.
Yeah.
I explored it all.
That's not this, but okay. So focal point is where parallel light gets focused to, and you can see the focal point up here, as well as down here. Notice that the focal point is on the right side of this and on the left side. They both have focal points, but we call one like the positive and one the negative focal point. we'll talk about that. I'm not exactly sure what terminology I want to use. I might use f and f prime. We'll see as we go. We'll see what makes the most sense. All right. Center of curvature, you're welcome. You can cross it out. We only use center of curvature with mirrors. And we're not doing mirrors, really. So just, who cares? All right. And then lastly, real images versus virtual images. So real images, where light converges at a physical location in space, and a virtual images where light appears to converge but not at a location in physical space. Yep, I'm going to pass it around.
Way to ruin the surprise.
Okay, real versus virtual. So I'm going to pass around a mirror. I'm going to pass around this little penny demo. You may have seen this penny demo before. But what you can do is, if you look straight down from the top, you'll see a penny. And if you hold it up in front of you at like a 30-degree angle down, 45-degree angle down, you'll look and you'll see the penny. Try to touch the penny, and you'll freak yourself out. And you'll freak yourself out. So once you see it, just pass it to the table behind you or next to you. And then a virtual image, I'm going to pass around this mirror. Look at the back side of the mirror. You'll see a virtual image because you can see yourself in it. But if you went to touch yourself in the picture, it sounds creepy. If you went to try to find the physical position of yourself in the image, you couldn't do that. Like, you can actually touch the spot where the penny is. Like, where you can see the picture of the penny, you can touch that. You can't actually touch where your face is in the mirror. Like, even if you touch the mirror, you're not actually touching the spot where your face is. Okay? So that's real versus virtual. So virtual images only appear to be in a certain place, but they aren't actually. All right, ready? Here we go. Virtual image. Bam! You can see your face, your beautiful, shining faces. These are all virtual images. These are all virtual images because you can't actually, like, you look and you're like, where are you? It's like, oh, I'm in there. Well, like, you're not back here, right? There's not a real place that you are. So that's virtual versus real. Real images form at an actual place in space. Virtual images only appear. This is a real image. What you see on the screen, that's a real image. The light is actually converging here in space. Okay? Huh? Yeah, when you look at yourself in the mirror, you're seeing yourself flip from what you actually are. Because, like, what looks like, because, right, you're flipped around, so what you think is your right is actually your left.
I hate that.
Yeah.
Just because, like, I don't know what I truly look like.
Yeah, you never really know what you really look like. Because even if you look at, like, a picture, someone takes a photograph, even with that, there's diffraction going on through the lenses. So, like, everything you see is going to be filtered one way or another. So, like...
I have two mirrors to, like, place against each other to see, like, my true self.
Oh, yeah?
Fix my hair in the morning. So, I go that deep.
That's terrific. That's terrific. All right, any questions on the front page here?